was a good job. 10, do 211, 212. I'm not sure exactly the date, but let's do this problem. It's next up on our list. Redundant connection. So this is, I'm gonna do it. I know there's a DFS way and a BFS way, but I watched the DFS, or not DFS, Union Find, and I think it was a good practice to do it. So basically, if I understand this question, it's a bit complicated, but given some undirected graph, all these edges, find the redundant connection, meaning if you could remove it, it would prevent a cycle. The way we can do it is with Union Find. Union Find will prevent you from adding onto the group if the connection already exists, because if you add it again, then that would be another way to get to that, and then that makes a cycle. So in this case, 2, 3 would be returned. So we have to make two functions. First, let's call parent, which is going to be an array. We'll say I for I in a range of length of edges, right? So for each for right now, each node or each value is its own parent, right? 0 it reports to 0, 1 reports to 1, and vice versa. But now we'll change that. We need to make two functions. So def which is find, which will take x and y, and then make def union, which will be x and y, which means to add these together, and it will return some boolean, right? So we'll make these two functions. So then we need to, for every uv, right, in edges, right, we want to call if not union, I guess uv, then return uv, right? Otherwise, return nothing, right? So that's kind of the logic, right? You basically kind of build out the, like, organize them together, and as soon as you find another set of edges, right, then we'll be like, oh, don't add that, because that's gonna prevent. Because if we report, look, for example, this one, if we find, okay, we find 2, find 3, and they're gonna report to the same parent, meaning they already exist in this set of group. Don't add it, because that's bad, you know. So, because if you add it again, then that's another way to get through. Another way to get through the graph, right? So yeah, now let's do the actual logic. Find. Okay, so find, we could do it recursively or not. So let's do it recursively. So if parent of x equals parent of y, return, I'm not sure. Okay, what do we actually find? So find is to find the parent. I guess just return parent x. I don't think it matters, right? Right? Otherwise, return, or I guess find xy, I guess. Oh. Okay, so does that even, oh, no, I'm doing this wrong. No, we want to find some node, right? Find a node and find its thing. So if parent of u, or if u okay, if parent of u does not equal u, right, then we need to keep going. So parent, I guess u equals find parent of u, right? Eventually we'll keep going and we'll find it, so we can just return parent of u, right? So yeah, this is the recursive pattern. So keep going up until you find it, right? Then union, this is the more complicated one. Union is to merge the two together, right? So you merging the two together will we have to merge them together. So first is to x root, which will be find x y root. So if x root equals y root, if they have, that's how we know root. That's how we know if they're the same. That's how we know if they're in the same component or same sets together. If they are, then that means they belong in the same component. So we don't want to add another one, or false, right? If they are different, that's good. That means it's a new path that belongs in a. It's nice to add them together. So we can say we'll add parent of I guess x, or I say y root equals x root, right? And then we can return true. So we can skip that. So that should be good. I think this should work. I'm not sure exactly. Oh crap. Maybe we can add. We'll do +1 to prevent some extra stuff, you know. Ooh, that's very nice. Let's see if it works. Probably a short video today. Nice. Alright, thanks for watching, guys. I'll see you guys tomorrow. Peace.